Linear programming application, solving problem using Microsoft Excel. This problem is taken from the Russell and Taylor 10th edition. So this company is trying to determine what's the how to minimize the total mileage of their truck. So they have these customers, I think 12 of them, and then they have only 8 trucks. So where they're going to send the truck to minimize the total mileage, total miles driven. At the same time, they want to achieve 80% of the capacity. So these customers have capacity, so not that everyone will give the truck 100% full load. Some of them will only give you only 71%. So the company wants the truck to be full with goods so that they can ship more material. So I have copied this data in Excel. So this is the data, and then we'll have to prepare this. We have to clean this data in a way so we can use this solver function. So I'd like to make a copy of the data and keep the original data, and I'll name this as clean. So because we're going to do a whole lot of things before we use the solver function. So to do the cleaning, we need to, let me insert some stuff. A lot of this thing will make more sense as we go along, so it might not make sense immediately. So like many problems we have solved using the linear programming function, in this case we're going to assign trucks to each of these customers. So I'll move this mileage right here. I'll copy this customer there so I know whose mileage is what, and also copy this truck right here. So the solver function in Excel will start with zeros, and then it will fill with some number after performing all the operations behind the scene. So I'm going to name this cell as assign. I think GN, whatever, doesn't matter. So total sum of these, so they have only 8 trucks, so, and they're probably 12 customers. So the sum of this cannot be more than 1. So they're going to assign this truck number 1 to one of these customers. So in the constraint in the solver, we'll put that this sum is exactly equal to 1, and copy down. And then similarly, this will be less than or equal to 1 because not all the customer will receive trucks, because we only have 8 trucks to assign. Also again, we'll say assign here, and then we'll calculate the total mileage here. So simply is equal to sum product. All of these, so there will be only 8 ons here, and everything else will still be zeros because we have only 8 trucks, and whatever the truck we assign to a particular customer, it will multiply that mileage, corresponding mileage, and give us the total miles. So we have total 8 trucks mileage there. And now they have a capacity constraint that they don't want to send to the truck to a customer who does not provide a whole lot of goods. So they want to send the customer going to make more. So I'm going to do 1, 2. So this is the capacity given for these customers. So for example, customer A, if you send a truck to that customer, they will only fill 89% of the truck, and about 11% will be empty. And their desired capacity, so they want to have at least 85%. That's given in the problem. You can go back to there, and then actual we're going to calculate using that sum product function. We'll simply do sum product of this. So whatever track we assign to which customer, it will multiply with the corresponding number here to find the actual capacity. Now these are 8 numbers, so because we have 8 tracks, we'll divide by 8 to have an average capacity, because this 85 is the average capacity given for the desired, they want to achieve at least that capacity. So we have all these things set. Now we can go to the solver function. Before we go that, I would like to make a copy of this file, so in case if I mess up, I can come back and work on, I don't lose anything, because after I solve, all this number will be replaced by something new. So solver, we're going to minimize the desired. Max is select by default, so select the minimize, and then it will change these variables. And then I'm going to use the simplex linear programming, add the constraint. So this should be exactly equal to 1. We have to add also one more constant for this, that none of this can be a half track, so they're either 0 or 1. So it's a binary, we want only binary variables there. Add, and also this should be less than or equal to 1, because we don't have enough tracks to provide all the customers. And then one more constraint, this should be more than equal to that desired capacity. So we want to achieve at least 80%, 85% capacity. So I think that's all this. Why do I have the, let me do that again. So that, okay, I think that's all. So that's the solution to this problem.